There we go.
It's supposed to be a hallway. There's always a security guard.
Well, there's cameras in literally every hallway. Literally
Yeah,
all
but
of them.
if
And
you're doing
it's
it
for
in a
sure.
hallway, you're gonna get stopped like immediately.
Yes.
At
The,
least do it in like a hallway where there's like barely any teachers.
well, it's just one of those. There's not a lot of logic and reasoning at the start of these activities. It tends to be more of a heated, emotional. There's still cameras there. There's still cameras there.
Not in there.
Not in, but those doors are all locked.
Not always.
Yes, always. Yes.
I walked in there before.
Only when it's open for an activity, not when it's pitch black. Because that thing's pitch black when it's off. If there was any light at all, they knew you were there. I'm just saying, because I do go in there sometimes.
And it is, you know, it's unlocked the building. They don't carry schools after school, so they're setting it up. So it's unlocked the entire day. Yep.
Because I have to go and get the key for one of our activities. All right. We are going to be in our workbook today. So, it should be page 11. Which is letting us practice our putting our expressions into words again, taking the words and making them into the mathiness. And then we're going to compare these. And we're going to hit a few pages in this workbook today. Like, we're going to go through a few of them. So, all right, stop looking at the video. Put your phones down. The video will still be there. Chill. Put it down. All right, so we've got here, students in Mr. Sanchez's class are converting distances measured in miles to kilometers. To estimate the number of kilometers, Abby takes the number of miles, doubles it, and then subtracts 20%. Renato first divides the number of miles by 5 and then multiplies the result by 8. I want you guys to try and write an expression for what they did. See if you can write this as an expression. Start with Abby. How could we write this? She takes the number of miles, doubles it, and then subtracts 20% of the result. All right, what do we think? Yeah. So we're taking our number of miles, which you can use X. I've heard several people say X already. You can use M for miles. Again, you can use happy face, heart. I don't care what we use. It's a variable. It doesn't matter. We're taking the number of miles and then doubling it. How do we double something?
Multiply.
By 2. Multiply by 2. So we could put 2M. You could put M times 2. Doesn't matter. It means the same thing. So she takes the number of miles and then doubles it and then subtracts 20% of the result. So how could we do 20% of the result? Oops. So just looking at the 20% of the result part. How do I make 20% of that? Yeah, so we'd have to do our 20%. We talked about percents yesterday a bit where we put it as a decimal first. So we're going to do 0.2. And then they said of the results. We need 0.2 of our 2M. There we go, so my colors match. So we have our number of miles doubled and our 20% of the results. And we have a clue right here. We're going to subtract in between them. So the way Abby's doing it is she's doing it like this. Feels like a lot. Let's look and see what Renato does. See if his is better. So we've got Renato is dividing the number of miles by 5 and then multiplies the result by 8. So we've got Renato. Boop. He's still starting with some miles. I'm going to keep using an M. So how can I write that first he divides the number of miles by 5 and then multiplies the result by 8? How can we do that? What does he do first? Divides by 5. So I could take M and divide it by 5. We can do that. And then we multiply the result by 8. What do we do then? Yeah, we can do it like that. Absolutely valid. Do I need to have those parentheses there if we look at this expression? Because everything's being multiplied and divided, which is the same step in our order of operations. So I could write this as 8m over 5. Absolutely valid. So I want to say who's right, but I know we don't necessarily know how to convert miles to kilometers. But will they get the same answer? How about that? What do you think?
1.68 miles is 1 kilometer.
Not necessarily even that we need it to be exactly right, but would they get the same answer? Abby and Renato. It's hard to see it from here like this, right? Let's see if we can do some mathing, adjusting things here. Looking at Abby's, is there anything we can do to simplify this? Because this is a mess. It's not really even distributing because there's no adding inside, but we can do this multiplication. So we've got our 2m minus 0.2 times 2. What is 0.2 times 2? 0.4 m. Okay, that's not bad. That's not awful. Can we do 2m minus 0.4 m? What is 2m minus 0.4 m? Say louder. Not negative, 0.4.
Oh.
No, it's all good. It's all good. Yeah, sometimes my decimal points get really, really small and it's hard to see, especially when we're in the back. So, like, 100%, I get it. So how about 2 minus 0.4? Yeah, I heard it, 1.6. 1.6 m. And we're trying to compare that with 8m over 5. Also known as 8/5 m. What is 8/5 as a decimal? 1.6 m. So will they get the same answer? Yes. Because they have the same actual decimal number. They just go about it in entirely different ways because there's more than one path through almost every problem that we come across. Abby went percentages and all kinds of things. Renato tried to be efficient. They're both exactly as correct. Okay? So, you guys wind up always in these workbooks with an absolute ton of space. You do not have to fill the lines ever. In fact, I don't think we ever use every line, ever, because they give you a lot of space. So, like, that's how much I use. The top part A, is just seeing what we get up here, what we did together. And part B is to say, why do they have the same answer? trying to get you to analyze it and look at it. Okay? So we are going to be practicing with these expressions. These are called equivalent expressions because they mean the same thing even though they look different. This is an equivalent expression to this, which is an equivalent expression to that, which is equivalent to all four of those. They all mean the exact same thing. Well, it was over there this morning. I must have carried it for a point.
You did.
I'm sure I did.
I watched you do it.
Well, I did it today.
Yeah, you literally just did it like big.
No. I did it in like algebra, I think. Okay, so we are going to look at the next page. And you want to build a swimming pool in your backyard. We are living that bougie life. We've decided we are getting a square swimming pool. We know that it's going to be square. That is the life we live. We have not yet decided how big our pool is going to be. So we're using a variable. We're going to call it s for the side of our square. Because the side of a square is s. Just because we have an alliteration. So we know we're going to plan a border around our pool. Because, again, that bougie life. And we need to figure out how many tiles to order, even though we don't know how big our pool is. So what we're going to do is we are going to compare these expressions to see which ones would be the border. So on your page, they have all kinds of things listed there. So it's these expressions. I just took this part because I don't need that part when we just talk about it. So we're comparing these expressions to what we think this border is going to be. So I want you to see which ones match the border. What do we think? And there can be more than one answer.
4s plus 1.
Look through all 1, 2, 3, 4, 5, 6 of them and see which ones may match. Because there may be, could be, hint, hint, probably is, more than one answer. I like my pool. It's a lovely pool. It's a very square pool. So I want you to look through all 6 of these and see which ones we think are going to match and which ones don't and why. See if we can think those through because I know some of us are already looking ahead at that. Yeah, absolutely we'll go to a picture. Totally fine. And the question is, does that match your board? And we're going to look at all of them. I am getting instructions on how to set up your Canvas course. They should be already set up. Okay. All right, I feel like we're wandering off topic, so we're gonna bring it back in. So, what do we think? Does 4s plus 1, 4 times the quantity, s plus 1, make a border for my very lovely and high-tech pool?
Yes.
Because I have a side plus 1. And I have a side plus 1. And a side plus 1.
It's the corner.
And a side plus 1. If I bring them all in, does it make a border for my pool? Yeah. Because each of these side plus 1s is one side plus a corner. So that one's absolutely valid. We have 4 sets of a side plus 1. So, cool. This is 4 sets of a full side I'm going to write the word plus corner. Or however you want to word it. So yes, we know this. I could draw this on my little picture here as the side plus a corner, the side plus a corner, the side plus a corner, like this. Because each of these is one of those 4s plus 1. I'm trying to make them colored differently. All right, do we see how that one works? What about the next one, the s squared? Will that make my border?
No.
No. What does that give me?
In the area.
Is the area of my pool. If I wanted to buy a cover, that's the one I'd need. But that's just the area of the pool. So that is not what we want. This is the area of the pool. So this one does work. How about 4s plus 4? Does that one work?
Yes.
Yeah. Because what is that? It's the same as the first one if we distributed it. If I list all 4 of my sides and all 4 of my corners, so that's 4 sides and 4 corners. So it's like individual pieces. I can come over here and say, well, I have 1, 2, 3, 4 sides, and 1, 2, 3, 4 corners. 4s plus 4. I've got that. So this one does work. What about the next one?
Yes.
It works? Why?
Because it's just the same thing. You just pull out 2s and times by 2 instead.
Yeah, if we multiply that out, that works. What this is saying, so we've got 2 sides, so there's a 2s right here. And then we're doing 2 of s plus 2. So I have a corner, a side, a corner. So there's a side plus 2 and a side plus 2. What they did was they took top and bottoms and took the sides out. Okay, so that's how they came up with that. Because what this is about is seeing that there's a lot of different pathways through. They took the top edge, bottom edge, and then did the sides separately. And I just unplugged my cleaner. There we go. So yes, that one also does work. Oh, I left it over there. So, yep, that one works. I'll call this one top and bottom. Sorry, my handwriting's gonna be trash. I have my backup stylus is here. Duh. Top and bottom plus sides. That's the way that they saw this one. Was they took long top, long bottom, and short sides. They did it this way. someone. Why not? What'd they forget? On the 4S, what'd they forget?
Corners.
They forgot the 4 sides. They forgot the corners. They're leaving my pool with open spaces. Can't do that. Fall in or have like plants growing at the edge of my pool. Ew, no plants at the edge of my pool. So they forgot the corners. So you gotta make sure you grab all your corners. Okay. I still forgot to pick up my stylus when I was right there. So this is missing the corners. So this one does not work. But the 3 of them that do work all look really different. They all look really different. So it's okay for our answers to look really different than our neighbors, than our friends, than anything else we see, because they can still be equivalent. That's okay. It's okay for our answers to look different as long as they mean the same thing.
Also, that would be the parameter of the 4S would be the parameter.
It'd be the perimeter of the pool itself, but not of my border. Yeah. All right. So we're going to look at one more bit. So we're going to look at the next page. And this is looking at things in a slightly different way, different space. So we're going to compare things now, kind of like how we compared those expressions, but it's even more vague. Even more vague. So what we have here is we've got P and Q are the price in dollars of 2 smartphones. And this book was printed a while ago, so they thought these were, bougie, nice, high-tech phones. At 64 gigs and 32 gigs, which right now is kind of midline. But we know, since there's 64 gig and 32 gig, one of those is bigger than the other. And then they tell us that P is bigger than Q. So P is going to be the bigger phone, and Q is going to be the smaller phone. And what we're asked to do is figure out which of these pairs of information are bigger. Which one's bigger? So we're going to start with just this first one. I've got a P plus Q compared to a 2Q. Which one do we think would be bigger? Why do we think 2Q might be bigger? Because it's being multiplied. Definitely a thought. I'm going to write something else over here. Because I know P is bigger than Q, right? So Q might be little. So I'm going to write this, rewrite my expressions here. I've got, whoop, wrong pen. P and Q, little q. And 2 q's, if I have 2 times q, that's the same thing as q plus q, right? Because I have 2 q's. So I have little q plus little q. Let me get that. Right? So which one of those is going to be bigger? P plus q is going to be bigger because the p is bigger. So that side's bigger. Since we know P is bigger. This would be buying a phone for you and a little sibling versus for just your 2 little siblings. I spend a little more. So we can spend a little more that way. Let's look at the next set. I've got P plus 0.8P and Q plus 0.08Q. What do you think? What do you think? Which one's going to be bigger? The P-based one or the Q-based one? Got P on this one. Whoop. And Q on this one. Or would they be equal to each other? What's up? Gonna go with equal? Why would they be equal?
We still know P is bigger.
Because you're multiplying.
Yeah.
0.08.
P would
Yeah.
still be bigger.
Yeah, because we could combine like terms on here, right? This is 1P plus 0.08P, right? We could write that as 1.08, right? So I have whoa, I keep using the wrong pen every time I use the highlighter. Goodness. 1.08P. And I can do the same thing with the Q. 1.08Q. Does that make it a little clearer? Which one's going to be bigger? Or do we still think equal? Remember, P costs more. P's a bigger cost. So the P will be bigger. Because what if the phone with price P is $1,000 and the Q phone's like $250? It's a burner. Definitely would cost more. When we have things like this with the 0.08, typically what they're trying to get us to think of is cost plus tax. It doesn't matter if the phone's more expensive or cheaper, they both get the same amount of tax, so P's still going to be bigger. The third one is a little tricky.
Q is bigger in this case.
We've got, using the highlighter again, I'm going to remember to subtract with pen. 600 minus P and 600 minus Q. What do we think? But what? What? What's up?
Q is a smaller number and it's subtracted, so.
And we're subtracting. We're subtracting a smaller number on Q. So let's say I have $600 in my pocket when I walk into Verizon. Because we all carry cash, you know, that's how it goes. And P is a $599 phone. How much money am I walking out with if I spend $599 on a phone and I have $600? Just a buck. But maybe Q, which has a lower price, maybe that phone only costs $100. How much would I walk out with in Q's situation? If it was a $100 phone, I'd leave with $500 still. So P being a more expensive phone, P being bigger means when I take it out of the money in my wallet, I have a lot less left afterwards. Okay, so in this case, our results face that direction. Oop. Because when you subtract, how should I put it in a place right? Or take away, when you subtract a big number, you have less left over. We have less of a remainder, if you like that word. Yes, dear.
Since you said there's many ways we can figure out how we just solve it with that.
Yeah, on a lot of times like this, when we have a situation and they give us something like P is bigger than Q, you can absolutely pick numbers and test things. Maybe you test 3, which is bigger than 2. Maybe we test 100, which is bigger than 50. make sure we understand what's happening, but you guys can always substitute in and test values if you're not entirely sure with what you've figured out. Excellent, valid strategy, okay? Questions on what we did here? Because I think that is all we're going to do for today. And there is not a new homework for over the weekend. So if you finished the Math Magic and you did the What Makes You Happy, you are 100% caught up. I'm going to talk about one thing we're going to do next week briefly just so that you hear it a couple of times. At some point next week, we will take eyes on me for a second. We will take a quiz that I do not grade as a quiz. What I do is I use it to pair you up because we're like that card thingy we did yesterday. We're gonna have a bunch more of those, and for every chapter, there is one that I pick who you work with. And so that little quiz that does not go in as a quiz grade, I use to pair you up. I do not even grade right or wrong. I go, oh, your brain and your thought process matches your brain and thought process, so you guys are going to work together. So I'm matching you up on the way you show your answers and things.
Doesn't go with the tables.
What's that?
Doesn't go with the tables.
Yes, for every chapter we will have at least one card activity where you have to move and work with someone. Probably not.
So it's not a grade like, you know.
Like, it does not go in the grade book as a quiz.
Usually.
Like, I don't.
If you fail, it doesn't matter.
If you leave it blank, the only downside is you get partnered with someone else who left it blank.
That's really right.
I was gonna say, that is also a gamble that no one else leaves it blank, because I also put the seating chart right next to me when I put them together. And then, like, if you chitty chatty with everybody next to you, and I'm like, oh look, all four of these people have the very similar vibe. We'll match you up somewhere else.
Don't do that.
Because by the end of the year, we gonna all be buddies.
Well, if
Like,
someone
yay.
does get 100, could you possibly put it in the grade book for like extra credit?
I was gonna say, I do have extra credit problem every week on the wall over there.
Yeah.
Challenge problem every week. Literally the blue bulletin board that's 6 feet from your face. It says challenge problem, very large. It says extra credit opportunity once per week. In the yellow box it says prime, use those papers.
Wait.